Welcome back to Physics with Miyoshi. Hopefully you enjoyed a quick trip to the Redwood Forest, and that's what we're going to talk about today. Really quickly is what if you know the height of an object and you want to find out how long it takes to fall, and what about the final velocity. We also want to look at another problem where we know how long it took to fall, what would be the height that it fell, knowing the time. I'm going to use one, we're going to use the gravitational constant of negative 9.8 meters per second squared, SI units, and the other one we're going to use English units of negative 32 feet per second squared. Okay, so how are we going to do this? If we know the height, then what we can do is we can simply use the equation. Distance is v0 times t plus 1/2 at squared. Now you probably use this equation lots. Again, remember that it's a derived equation. Is this equation back over here? We know that v0 happens to be 0 feet per second, so that can go away. Now, notice that I already drew my picture. I would have done that after reading my problem normally, but I already drew the picture. I labeled all my knowns and all my unknowns, and then what I want to find. I even put in the gravitational constant here. And you should do the same thing as you solve problems. Remember to draw a picture. It will help you out. So I know this is going to be 0 because 0 times anything is still 0. So then all I have to do is d is equal to 1/2 at squared. Well, I know a is my gravitational constant, and I'm just trying to find t. So let's rearrange this guy. I'll multiply both sides by 2 and divide by a. 2 and divide by a. So I end up with 2d over a is t squared. So now let's flop this over on the other side, and we can do that because it's an equality. And now I know that I can just put in there 2. Now the d, well, let's do this. My a is going to be negative 32 feet per second squared. The question is, why would my d, if I have a negative there, if I have a positive number here, 300 feet, that'll end up being a negative number that I'm trying to find the square root of. Well, if we remember our initial x, if you will, or our initial y is up here, and this would be negative. That negative just says it's going downward, so I can say it's going to fall 300 feet, or put a negative there. So that's going to give me negative 600 feet divided by negative 32 feet per second squared. And when we do that division, we end up getting 18.75 feet are going to go away. The second square is going to come on top. Notice that we can now remember that this is still t squared. And we can see by our units that we still have one more step because we want to find t. So t is the square root of that guy. Square root of 18.75 seconds squared, which is going to give us 4.33 seconds. And so we know now that if we had a tree or something, we dropped something, neglecting air resistance, that we would have, it would take 4.33 seconds to get down there. Now, to find the final velocity, that's a very simple problem. Now, all we have to do is remember that change in velocity, or acceleration, is change in velocity over change in time. And we can rearrange that equation. That's just v final minus v initial divided by time. V initial is going to go away. So then all I have to do is find my v final, is multiply a times t. And we know a is a gravitational constant, so that's negative 32 feet per second squared. And my time is 4.33, as we just found out. And we would get, that would be seconds. What do we get? We get 138.56 feet per second. And we see that it's negative. The negative again tells us that it's going in the downward direction. Okay? So that's how to find the final velocity and the time of an object falling from a height of a certain distance. Okay, so what about the other problem where we know the time and we want to find the distance? Well, that is a problem that we can look at very simply. We know there's a couple different ways to do this, but probably the easiest way is to remember that my V average is V final plus V initial divided by 2, as long as we have constant acceleration, which we do in this case because we're neglecting air resistance again. So we can find the final velocity knowing the gravitational constant. So we can, actually that's how we would find the height. But when we want to find the final velocity, we can just use this equation. V is V0 plus AT. V is V0 plus AT, which we know from before. That's just rearranging the average acceleration equation. So we know that the V final is our initial velocity, which is 0 plus A times T. Now we can just ignore the 0, or not, we add that in. A is G, so that's negative 9.8 meters per second squared. Multiply that by our time, which is 20 seconds. And we can see one of those guys goes away, gets canceled out, and it's negative. What is it? I've got that written down here. 196 meters per second. Again, the negative tells us that it's going in the downward direction. Okay. Now, to find the distance, we can again use this guy. We could also, if we needed to, if we wanted to, we could use this equation here, but this one is a little bit easier, I think. So we'll just use x. Well, I like to count V average. V average is V final plus V initial divided by 2, as long as we have constant acceleration. So now that would be V initial is 0, so we just divide this guy by 2. So that's 196 meters per second divided by 2 is, whatever it is, that is 98 meters per second. Okay? And then we can use this equation here. Distance is V average times time. V average times time. We know our V average is 98 meters per second. Our time is 20 seconds. Oops, that's a negative because it's going down. And we end up getting 1,960 meters, which is a long distance. It's over a mile, and that would be the distance an object would travel with no air resistance if it fell for 20 seconds. So you can see that these equations come in very useful. Again, I myself personally will probably never use this equation, or very rarely. I like to use these three and the ones up here, and just by knowing what they are physically, that will help me solve equations like this. And again, draw a picture, label your inputs and outputs, what you need to find, what you know, and then that will help you solve the problems. So, falling objects in physics. When we know the height and want to find the time and final velocity, or when we know the time and want to find the height and the final velocity. So, tune in again for more Physics with Miyoshi, and thanks for being here.